today we'll be talking on how we are releasing the code for these services, right, across our production environments. And in terms of when we started thinking about the continuous deployment pipeline, right, actually Manuel had a great talk today this morning, and we have a lot of like parallels with that, because we started thinking what our platform like product teams need, right, when they're developing their services. And number one thing they need is a deployment pipeline that matches their velocity, right? We have a lot of these teams that work on multiple services every day, bringing in new features and enhancements, and the velocity of change that is going on into this product is quite large. So we have like multiple hundreds of commits per day, and we need to match that speed, and we need to deploy all of these changes into our production systems. So number one thing, when we're thinking from what user needs first, it's velocity. So we need to match it. And then as we are rolling out these changes, we need to ensure that the quality of service is also not impacted, right? We can't just blindly roll out changes to our systems. We need to ensure that there is no customer impact and all our services have uptime. There is no performance degradation, so we need to look at the metrics that we scrape from these systems and make sure that everything is well there. And then finally, we also need flexibility in this deployment pipeline. In case we have some security patch that we need to roll out really quickly, which happens, or we have some bug that we identified in the system, we need to be able to react fast. And by fast, I mean like within an hour or like 30 minutes, we need to be able to release a version of software to all our production instances. And with the scale that we operate in, this becomes a challenge. But anyways, we started with these three ideas, and this was our like a starting point on what we needed to achieve out of the deployment pipeline. And I will hand it over to José now to actually go through the results first, and then we can dive into what we actually did.
So, good morning, everyone. You already know, because it was in the title of the talk, right? So we're managing around 15,000 namespaces. It's probably a couple thousand more by now, across 50 multi-region clusters. So you can imagine that it's releasing code to all of these namespaces whenever an engineer deploys a change. Like it's tricky, right? There's multiple problems that can come up with it. We'll talk about it more in a few minutes. So this equates to around 200,000 services because, as Iveri mentioned, Adobe Experience Manager is essentially a content management system. So you can think that each one of these 15,000 namespaces is a customer website. Multiple websites that you use in your daily basis are running on AEM. So you can imagine that deploying code to these namespaces is sensitive, because we could, with a broken change, bring the website of the customer down. So going back to the services, each of these namespaces consists of multiple services that are needed to maintain the website up and running, and also to publish content changes to that website. Now, when we started this initiative, our deployment frequencies were super bad. We were deploying changes maybe twice a month. And that's where all of this came from. So we wanted to find a way to understand, in the end of the initiative, how did we actually improve our release platform. And what we used for that were a couple metrics that probably a lot of you are aware of, which are the DORA metrics. DORA metrics are used across a whole lot of companies to measure DevOps efficiency. And what I wanted to show you guys here is basically I wanted to start the presentation by showing the current state, right? So using the infrastructure that Iveri will talk about next, how are we releasing code now? So basically, as of today, we're releasing changes to all these namespaces on a daily basis, and it usually takes around 72 hours, give it or take, since a developer commits a change to the master branch until it's in the customer namespace. Change failure rate is also very low due to the whole amount of steps that we go through until the code is released. And we can also restore, if there's any broken change, very quickly in about an hour. So yeah, these were super great results. And you saw that these 4 metrics are essentially what DORA metrics are all about, but we didn't want to tie ourselves too much to the DORA metrics because there's a whole lot of things that we can measure to understand if our specific team is efficient, right, releasing code, and also if it's safe. So one of the other things that we wanted to measure were the commits per deployment. So this was something that the whole rationale was basically trying to understand if our versions of code were easy to debug or not. So previously, before we implemented this strategy, this number was huge. Like each change that we were releasing 2 times a month had, I would risk myself saying maybe 100 or more changes to it. And now we're doing 3 changes per deployment, which is, as you can imagine, much easier to debug. It brings a whole less complexity to the system. So yeah, thumbs up to this result. Yeah, over to you.
Thanks. So we can walk through the actual infrastructure, right? How our pipeline looks like, and just to set up what we are actually deploying, right? So we have 15K namespaces, and each namespace looks something like this. We have like a dozen of services running in each namespace that provide these features to this platform. These services are also running in a replicated manner, in a scale, like a auto-scaling kind of way. So the CPU and memory consumption in each of these namespaces are also dynamic based on the usage rate. So these namespaces scale out or scale down in terms of number of pods and services that are running there. And this setup is quite identical across 15,000 of these. There is differences in terms of like configuration surface, like they are not all exactly the same, but they follow the same profile. Again, there's differences in memory and CPU, how much they use at a given time, and some like the way these services are set up. So application level metrics may be different between them, but overall they are mostly the same. Now, in terms of how we orchestrate and deploy these services, right? It's all like Kubernetes based. So in the end, it ends up all of them are just Kubernetes resource manifests that we deploy, right? And for that, we use Helm charts. So we package all of these applications into one single Helm chart, and we version them, and that's how we deploy it. Now, in terms of orchestration, like how we orchestrate to deploy all these Helm charts across this fleet of namespaces, we leverage a mix of open source controllers and the in-house developed ones. Now, on the right side, you will see the open source controllers that we use from FluxCD project. It's a quite popular GitOps-based continuous deployment project. From them, we use Helm and source controllers. So that way, we can create this Helm release, which is a custom resource object in Kubernetes, which has all the information on how, like what Helm chart to use, what version to use, and how to configure it. So it has all this information. Flux controllers discover it and install it in the namespace. Now, on the left side, we need something that will create this Helm release objects in our namespaces, and for that we have custom operator, which knows all the things around our application and our platform and what configurations to apply and how. So together, these two controllers work, and they basically install and orchestrate this whole thing across our fleet of clusters. So this is what we had already in place when we started this continuous deployment project. So technically speaking, we could that day already like release a version of the software everywhere, but we can't do it because we need to achieve reliability tenants, right? Like we need to ensure that quality of service is high, and so for that we need several things, and yeah. Maybe you can walk us through what we need to do that.
Yeah, so first of all, I would actually change this title up there to Achieving Safe Releases. One of the things that we focused on was we needed to have canary rollouts, so that we're sure that if we deploy a change that is broken, The only thing that gets broken is the pods that are starting up, but we're still serving the traffic to the customer website from the old deployment. Also, we needed validation metrics, right? So we need to understand if when we're deploying code, if that code brings any problems or not. So we needed to come up with a set of metrics that would allow us to have a visibility over this entire 15,000 namespaces in an easy way. And this was tricky because you cannot come up with metrics that are application specific. You need to look in a higher level and basically look at simple things like percentage of environments that are coming up, percentage of environments that failed. So basically we look a lot at percentages because when you're working at this scale, like you cannot be looking at specific errors and you cannot tie yourself to application specific errors. So we are not looking at exceptions. We're not looking at anything else. We're basically looking at if pods are starting up healthy or not. And also, we need observability to be able to see all these metrics. Our observability stack needs to support this amount of environments. It was actually a trick. We actually had some issues when we started adding too much metrics to this platform. Because when you have too much cardinality, and once again, that's why you cannot bound yourself to application-specific metrics like exceptions and so on, our observability stack would just blow up because there's just too many metrics to look at. So yeah, speak a bit about Thanos.
Yeah, sure. Yeah, so at that point we already like defined some metrics that we care about, right? And as José said, like we can't look at every single metric that every application is emitting, right? Because that would be too much. So in the validation metrics point, we fixed that problem by defining like high-level metrics of what we care about, right? Like what does it mean for us, for application to be healthy? And that includes things like when pods are up and healthy, right? That means that its probes are reporting health, right? And probes can check minimal set of things that ensure that application is started and can receive requests, right? But we also incorporated things from Canary rollouts, right? Because Canary rollouts are more complicated. They run with stable and Canary version for brief periods of time, and they evaluate when it's safe to move on and increase the traffic to Canary versions, right? So they also emit higher level metrics to say, it's safe, let's increase the traffic here. So we incorporated these higher level metrics in our set of metrics that we will be looking at, so that we could allow ourselves to have like a global view of what is like what is the health of our applications looking like. Now, in terms of like how we're dealing with the cardinality, because that was a problem, we worked out that problem by having Prometheus instances scrape some subset of namespaces, so 5-10 namespaces at a time, and we have this fleet of a lot of these Prometheus instances running, scraping these subsets of namespaces for all the metrics that they emit. So the metrics that they gather is a lot, but because we only scrape few namespaces, the cardinality is fine. And we also have a low retention rate on these Prometheus instances. So that's our first layer of the observability stack, where we have almost all metrics that we emit. Now, because we have so many of these Prometheus instances, when we need to look at what's going on globally in our clusters, we can't just simply query each Prometheus instance one by one, right? So we need a global place where we can aggregate all this data, and for that we use Thanos. And Thanos is also this engine, observability engine, which allows us to ingest way more metrics that Prometheus can and have a higher retention rate, and it's way more scalable. However, it also can't just ingest all the metrics, right? So at the Prometheus instances, we do also cardinality reduction. So we have recording rules and all these techniques to basically process, aggregate some of these metrics together, drop some of the labels that we don't need. And once they look that they are pre-processed and they meet our standards, then we push them to Thanos. And then Thanos becomes the single point where we can find all the data that we need, but the data is also high-level metrics data, not low-level. So at that point, what do we need to do? So in Thanos, we have these global sets of metrics available that tells us whether the deployment that we rolled out was green or not, whether it went out fine and the environment is healthy. So now what we need to do is, like, if I'm an engineer and I want to release a version, I just want to understand how this version is behaving across all our environments. So there we calculate some very basic derivative data, like, hey, like, how many namespaces are still pending to receive a software update that we rolled out, how many have already received it and they are complete, and how many are in degraded state, meaning something is going wrong there. Maybe they're not entirely failed, but some metrics are not performing so well. We don't know which, but we know that they're not performing well. So we calculate these 4 or 5 basic threshold metrics, and they tell us the overall state of what's going on. So then we have those metrics, and we do 2 things with it. When we release a new version of a software, we know those validation metrics before we release it, right? So now we have 2 things to compare. When we released a new version, how these metrics changed compared to the one that we were running before. And what we want to ensure here is that when we release a new version, even if it meets our high-level thresholds, we also want to ensure that we are not degrading the performance, right? We don't want to introduce a negative change into our environment. So if we see that a Canary version is performing worse than the stable version that we had before, we will mark it as something to investigate, and we will have to look into it manually and halt the release pipeline at that point. And then finally, all these metrics are just metrics, right? We need to introduce some kind of thresholds on it. So what is our service level objective? So here we define what it means, what are some of the thresholds that are acceptable for us against these metrics, right? So what is the acceptable failure rate for us? Because not all environments are going to come up. There will be some failures there. So we need to understand how much failure tolerance do we have, or how much tolerance do we have for namespaces that are still pending to receive the change that we deployed. Because across all of these environments, it's not practical to say that we accept 0% failure rate, because then we will never release it. Anything out there. Yeah, so we do all these steps, and that informs our decision whether we are going with the release of this version of software or not. Now, this is a lot to do by hand, manually, and this is not practical, and it will take us also like a whole day to calculate all of this. So we introduce this service version orchestrator that goes to Thanos, fetches all of these metrics, calculates this data that we just went through. And when it sees that all these quality gates passed and we're good with the version, it then goes to our rollout mechanism that we covered already and tells what specific version to use there. And this way we kind of close the loop of deploying changes to our infrastructure. However, there is still some pending questions around how we release the version to all our namespaces. Because if we just say that, okay, we want to release this version, and yeah, all our namespaces get it all at once, we will find some problems there. And yeah, there's a bunch actually.
So let's talk a bit about managing risk. So when these metrics are green, right, and everything is fine, the system realizes that a new version can be deployed, there's still a lot that can go wrong because we have so many services that need to be updated. And we want to make sure that we reduce the risk. So we want to be able to essentially control how many of all these services are updating at any given time. Yeah, so this is essentially an illustration of what the issue is. It's very simple. When you have a namespace that is up and running in your cluster and you want to update it, right? I mentioned before, we're doing canary rollouts. So you will create a replica and you will, with the new version of the code, right? Now the issue is when you have a hundreds, maybe thousands of these services per cluster, you will be duplicating the load, right? So this will be necessarily a problem, and it's something we need to control. This will for sure blow something up. You will either have resource shortages, you will maybe reach the limits on some Kubernetes API, something will go wrong. So we need to be able to control, after we know that the deployment is safe and everything, and we can start deploying, we still need to have some control over what is being deployed at any given time. So yeah, we're doing a bit of cluster capacity management in the sense that we're controlling the scope of the release by doing smaller releases in a sequential manner, right? So it essentially looks like this. This was a plan that we had to spend some time understanding what was the best way to achieve it, because we want to manage risk, but we also don't want to be too slow releasing the code. Because if you're too slow releasing the code, it also means that if you want to roll back, you will also be slow, right? And we reached the point where we were in a limbo, where we were balancing between having a maybe safer a way of releasing this with way more tests, way more steps, but also being slower, or just being pragmatic and releasing the code fast. And if anything goes wrong, we can just stop, roll back very quickly. And in the end, that's the way that we went for. So what we're doing is, every time that a developer commits a change to the charts repository, that change will immediately be rolled out to all the stage environments that we have. So stage environments are essentially environments that our engineering team uses to test everything. And there's hundreds of, if not maybe thousands of environments out there on those stage clusters. So they're very good test subjects. So we release the code immediately there, and the code stays there for 3 days. And for 3 days, like, we can be very confident that if something goes wrong, people will find it. And that's been the case. And after these 3 days, if everything is fine, we deploy the code to our Adobe environments. Now, this is environments that are maintaining Adobe websites and internal tools. Yeah, and then we start the actual customer rollouts. And even on the customer rollouts, we go by percentiles, which is what makes sense, because we need to make sure that at any given time, we're not rolling out more than a few hundred namespaces at once, right? Yeah, and if the good thing of this is, if anything happens, if we have a customer that starts complaining when we're on the 20th percentile, we can just stop the rollout manually, and the system will not release anything else until we decide what to do next. And what we can do next is usually either we roll back the change, or we create a patch and we roll forward, which is what I think, if I'm not mistaken, we do almost every single time. Yeah. So, yeah, that's pretty much it.
Yeah, that was the end state of the whole pipeline that we developed, and we released it at that point. And it's been running for some time in the beginning, but we started receiving engineering feedback that engineers wanted to know, like, hey, what version are we rolling out? What is the state of the rollout? In which percentile it is? Is it successful or not? And so forth. And even though we have all the dashboards in Grafana detailing this, this was not easy to get to the engineers, because also the process changed. So the feedback was that we were getting asked on Slack a lot, what is happening? And the thing we didn't anticipate at the time was that, hey, we needed some other way to communicate this information from our orchestrator service to our engineers. So we did a Slack integration, because that's where we were getting all these questions. That's where engineers were like consuming like data on what was going on. So we did a quick Slack integration that this service of ours is sending messages to the Slack every time it promotes some version to production or updates statistics on how the version is doing in our production clusters. Put it in Slack, readily accessible to all the engineers that need to know. So that was something that came out of pragmatically, like we didn't anticipate, but we saw a user feedback and we implemented it. Another thing that came out of it is when José was mentioning, when we find a bug and we need to fix it, we usually patch it and roll forward. And for that, we need to obviously do some manual steps. And so it happened a few times. So we also automated that, and we did a Slack command to create this PR that we require on the GitOps to push a specific patched version in some subset of environments, so that any engineer who discovers it can do it themselves as well. And then we also implemented some other commands, again, proactively. Like, we found out that we are receiving a lot of questions around certain topics, and after doing it for a while, we decided to automate it. So one thing was that sometimes during holidays, when whole engineering teams are out, we want to freeze rollouts, because otherwise, if something goes wrong, there is a limited amount of people to debug it. So we introduced a command to halt the release to production environments and things like that. So that was our Slack integration. And that's the state we are in right now. Now to shift to the takeaways. So what was learnings from all this experience? We would summarize it in, I guess, 4 points. So number one is measuring the baseline. This is something that José talked in the beginning. This goes back to the user needs, right? Like, what does our users need? And they needed velocity and the ability to safely release code. But how do we measure this, right? Like, how do we measure, like, what's the current state and where do we want to go? And so, yeah, measure the baseline, because it can inform the decisions that you have to make, but also keep you on track. Like, if you are diverting from it, you will know based on the metrics that you gather. And so for us, it was DORA metrics. There is other types of metrics that measure the DevOps efficiency you can use, and also try to add something that is specific to your organization. Don't feel limited to stick to one set of metrics. Observability and instrumentation is key for us, because technically we already had all the ability to release code as fast as we wanted before we started this journey. But we couldn't, because then it wouldn't be safe. So we need all this telemetry in place, in real time, available to our system, so we can make informed decisions. So think about how you're going to instrument your code. Think about cardinality, and you need to solve these kind of problems beforehand. What are system constraints? This is also an important factor, because it informs so much of the decisions that you will have to make. So for us, it was, again, this health of our environments, right? We have a very little threshold in what we can accept going wrong. So we need zero downtime. We need to meet scalability challenges. Again, we can't break a whole cluster. It will be a total disaster, right? And you can actually break Kubernetes clusters if you try. You don't have to try too hard. You can break them. And minimize impact of regression. So think about those constraints that you have to work around with. And finally, we were more pragmatic than we started with pragmatic approach. Basically, we didn't implement something that we didn't think we needed to validate, or we didn't assume too many things. So we released a version of the deployment pipeline that met our basic requirements, and anything else we just found out through engineering feedback. Like all these Slack things, integration came afterwards, because we didn't have it and engineers demanded it, and it was overwhelming us, the amount of requests. Only then we automated it. So this approach of automate when you really need it kind of worked well for us in that case. And then that's it. And we used a bunch of open source technologies that basically enabled us to build this. So shout out to them, like especially on the monitoring stack with Thanos and Prometheus, and then on the orchestration side with Helm and FluxCD. And yeah, this is it. Thank you for listening.
I have this amazing cube. It's a microphone. Thank you very much for the talk. We are already in break time, but maybe there's still one or two questions. Yeah, okay, I see. I was told I can throw it, so I hope I hurt nobody.
This is amazing cube, by the way.
Hello.
Hey.
So, short question. How do you deal with the concurrent releases, the ones that might conflict one with the other? Do you serialize them, or you run in parallel as well, rollouts?
Concurrent releases meaning like we push like 2 different versions
Yes.
of software and all. Okay, so in our pipeline there is no concurrent releases, so we only release 1 version of software in a subset of namespaces at a time. We validate that it was successful, and only then we release a next set of versions.
It's like a train track, right? You could have one, I don't have slides anymore, but you could have one on the 50 percentile and a new one on the 20 already. And they keep on flowing, so it never stops. We don't have to wait.
Sort of in parallel.
We don't wait for one to finish to start a new one.
Okay.
Yeah.
Any other questions? Well, that's that. Right?
Wow.
Nice.
Well, thanks a lot for the talk. Very interesting. I was wondering how you deal with application metrics in case. I mean, we heard that you roll back if your let's say infrastructure code fails. How about if I don't know, specific websites get slowed down or do have performance impact on application level?
Yeah, that is a great question. So we delegate where we can, right? And we leverage the metrics from those delegated services. So for example, you mentioned websites, right? So we use Canary rollouts a lot for rolling out a new change. For example, we use Argo rollouts as a way to instrument the new version of the replica going on. And with any kind of Canary style of rollouts, and Argo rollouts is one of them, you define a set of application level metrics that give the rollout mechanism a go ahead or not. So it's usually like red metrics, right? Like error rate, duration and stuff. And that rollout mechanism will decide if you are not meeting those thresholds, it will not promote it, right? So it will roll it back. And it will roll it back and then set the status to degrade it. Now, from our perspective, we don't need to know about all the things that is going on in the decision to roll back Canary or not, because that is done by another system. What we care about is, have you rolled it back? Has that system rolled it back? And that emits a metric that tells us, yes, we rolled it back and now it's in degraded state, or no. So that's all we need to know on our end. So and we do the similar kind of approach with other services as well. Wherever we can delegate that kind of decision making to other controllers, we do that, and we just ingest the high level ones.
Thank you very much.